Hey YouTube, what's going on? Here is Maths Entrance Test 13 Plus for Year 9 and we just continue. That's the part 2. So we continue to explore percentages, ratios, and estimations, and also on top of that I'll just give you hints how to cope with equations and system of equations and how to apply it to the problems. Alright, so before there was the basics, and we actually figure out how to solve different types of equations from linear one to quadratic. So we also touched fractional equations, we worked with fractions, we understand what percentage is. So here is a bit more complicated questions, so mostly connect with word problems, but okay, let's see. So don't forget to subscribe, guys, and share these ideas to anyone who interested in it, and we started. All right, so first of all, I'm going to start with estimation. So what estimation means? So, for example, you would like to estimate what's square root of 10 without using calculator. So how you can do? So you can, first of all, estimate within to the nearest, numbers that are squares, because you definitely know that square root of 10 is more or equal, or strictly more than square root of 9. Okay, that's the lower bound of estimation. Square root of 10 also less or equal, so taking the next square number, which is 4, and square root of 4, you'll have 16. So the good estimation on top of that is square root of 16. So at least you know that square root of 10 is between 3 and 4. That's good. But what if you want to have like quite great numbers? Let's say square root of 70. So how to find the estimation that's very close to it? Okay, so again, we try to estimate between two square numbers and the left boundary. Okay, let's try to remember 64 is a good one. Okay, so 64, if you evaluate the square root, you'll have 8. So obviously the nearest one is going to be 9, which is simply square root of 81. So your result will be between 8 and 9 for square root of 70. But can you estimate more precisely? Alright, so no problem. First of all, let's have a look here. Square root of 64. Let's just measure distance. So 64 and 70, the distance between those two numbers is 6. So what about 81 and 70? So that's about 11, right? So you obviously think that square root of 70 should be close to 8. So that's why, okay, let's try to take 8.5. So your estimation might be between 8 and 8.5. And to check yourself, just take 8.5 and times itself. Okay, so you multiply by 8.5. So simply you can, because it's without calculator, so you need to be able to do without calculating. So to save your time, I just do it quick here, and I'll get, if you calculate precisely, it's 72.25. And you're actually right, because your estimation is very close to square root of 70. So that's why your estimation is between 8 and 8.5, but very close to 8.5. So you may take the next step. So the next step is to take 8.4 and do the same. So 8.4 times 8.4, and you'll get more close estimation, which is 70 and 56. So now you know that your value definitely is between 8.3 and 8.4. And if you satisfy, so you can also check what 8.3 means if you try to multiply those two decimals. And if you do that, you'll get 68 and 89. So obviously in this case, what you can notice that 8.4 is closer, because the difference between real square root of 70 and square root of 70.56 is about 0.56, while here is a bit more. So your estimation again closer to 8.4, but if it's okay, like if you need to stop at one decimal place, so you can write your answer as 8.4, and that's will be enough. Okay, so your estimation, final estimation is 8.4. Okay, so where you can meet this sort of example, so that's estimation. So for example, you need to estimate specific expression. Let's say without using calculator, let's try to estimate. Let's take 98 point, let's say 03 plus, let's take 2003 squared. So, and everything you need to divide by square root, let's say square root of 15 plus, let's take 96. Okay, that where you need to estimate. So estimate without using calculator. Okay, so your estimation need to be based on rounding, right? In this case, you need to round up to decimals because it's easier, right? So your first trial, so round to, no, decimal, I mean to units. So round to units. So round to units means you only leave your whole number or integer, and you just get rid of or discard the decimal part according to the rule of roundings. So in both cases, if you take 98.03, so you cut your number and say, okay, 98, so next goes 0, so 0 doesn't have any effect on 8, so your estimation after rounding is simply 98. So here's 20.03. You do the same before squaring up. You're just taking estimation that it's about 20, and then you raise the power 2. So 20 squared, that's your estimation, simply 20 times 20. So what's in the bottom part? You've got square root of 15 and plus 96. Okay, so nearest value is square root of 16. If you take that, that will be about 4. So in total, you'll get 4 plus 96, which is 100. So that's your pretty nice estimation. So you're not stated to which actually number, to which digit you need to round. In this case, you freely feel free just to estimate and round to the whole numbers, because you'll save your time, and that's how estimation works. Later on we'll calculate by using calculator and see what's the difference. So what's the percentage error? That will be in the next question. Okay, so 98 plus 20 times 20, so it's 400. 98 and over 100. So you'll get 4.98 because you just simply transfer decimal point 2 times, and that's why your decimal point goes first to 9 and then to right before 4 and after. So right before okay, after 4 and before 9. Yeah, that's will be precisely. So that's your estimation. Okay, so if you need to check your answer, and for example, the next question might be set up, so using calculator. So try to give an exact answer to, let's say, correct to 2 decimal places. All right, so now we're taking calculator and do that using calculator. Okay, let's see. We've got 98.03, then 20.03, which is squared, and then everything everything we divide by, again, expression square root of 15 and plus square root of 15 and plus 96. So your final answer, correct? So first of all, I just dropped the answer. How many digits I have? So 9, 9, 8, 6, 5, and something. Okay. Anyway, that's my answer. Now I need to round up to 2 decimal place. So that's my edge. And now what I'm going to do, I just need to round. So I've got 499 and I've got 8 in the end. So what I'm going to do, I just simply need to say, okay, 8 is more or equal than 5. So I round up. And what I will have after rounding to 2 decimal place. So I'll get 4. So here is I got 0. So extra 1 goes here and I'll again get 0. And extra 1 goes here. So to instead of 4, I'll get 5. So one more time. Let's see what happens. So when we round up 8 and 9 gets 1 extra point, instead of 9, I've got 0, but I've got new 1 appears here, right? So because actually not 0 but 10, right? So 1 unit goes to tens. So 9 gets 1, so it becomes 10. So you've got 0 here and extra 1 goes to the whole number, so 2 units. So that's why I've got 500. And actually, because of two decimal place, you cannot discard those zeros, so you need to leave them. Okay, so that's your number. This is an exact answer, correct, 2 decimal place. All right, so now you might be asked, okay, now let's go to the percentage. So what's the percentage error you've got during estimation? So percentage error, how to calculate it? So you're taking, let's say this is X stays for exact value, and estimated, stays for estimated. So I'll just one more time write that. So this is estimated, stays for estimation. Okay, how to calculate percentage error? So definitely you need to have the difference between, let's take exact minus estimated and over exact value. So, and the result you multiply by 100%. So that's normal practice how you work out your error percentage or percentage error. So let's calculate in our case. Now using calculator, let's do it. So exact value corrected to decimal place is 500 minus 4.98, and we divide by exact value, which is 500. The result we multiply by 100%. Okay, so let's calculate percentage error. So that's percentage error here, and let's see how much exactly we got as the error. So what we're gonna do, we're going to 5 subtract 498, and the result we divide by 5. So we've got 0.004 multiplied by 100%. That's the result, okay? So if we multiply, we simply transfer a decimal point here. So we've got 0.4% of error. You see, that's quite like small error when you round up actually to the nearest units. Okay, that was rounding procedure to nearest units. Okay, so that's how you can estimate and actually compare. That also the topic connected with, comparison, like which number is bigger. You have, let's say, several fractions you want to compare. Let's take, so 3/4, or you might, find, the odd number in the sequence. So that's again based on comparison. So for example, you have 3/4, you've got, so let me see, what's the best way to pick up another number. So let's take, okay, so let's take 75%, right? And let's take 0701, so which is odd one out. Okay, so that's the game based on converting into one format and then compare. So just compare in one format. So let's go to decimal. So 3/4, in order to get decimal, is simply multiplying by 25, and that's why your result will be 75/100. Okay, so that's 3/4. We've got that. So 75% is simply 75/100, so that the same. And 0701, you definitely see that that's different, right? So 0701 is simply 701/1000. Okay, that's normally the case. 1, 2, 3, you check yourself. Or if you don't want, so if you want to compare, you definitely need to erase 1 0 and put the decimal point on top. So you see clearly that they are equal while this is less. So your right number is less. So that's why this is the odd. It means different from all other numbers in the group. Okay, so that's based again on comparison. And if you want to compare a fraction, also you need to come to the common denominator. So if you want to compare different fractions, I don't know, like 7/8 and probably, let's say, 25/say 26. So in this case, how to compare which fraction is bigger? So there is the way to align numerators or denominators. So if you decide to align denominators, so you take in simply this denominator and multiply the bottom part and the top part by 8. So if you want to align denominator with 8, you need to multiply by 26 the way back. So you take in 26, multiplying the top part and the bottom part. Now you've got, you don't need to calculate denominators, but you see they are the same. Yes, 26/8, that's the same as 8/26. Now, so what are you gonna do? You just need to say, okay, I've got 26/8 and 7/26. That's what you've got. So 7/26. You've got the result like 7/20 and 7/6. Okay, if you do manually, like mentally, and the second fraction is 25/8, you do the same. So you just decompose 20/8 and you add the rest 5/8. This is the case, will help you to do it mentally or just using minimum like efforts. Okay, so we have the same denominators, which is 26/8, and here's 26/8. Now what we're gonna do, 7/20 is 140, 7/6 is 42. So we add them up and we get 182. So if we calculate the right side, we've got 160, right? And 5/8 is 40. So definitely the right side, the top one, is greater. So that's why it simply means that here the right side and the right fraction is greater. So coming back to your original numbers, you can say that 7/8 is less than 25/26. That how are you supposed to compare? Okay, we've got through estimations, we've got through comparison. Now let's go to the percentage. Okay, so percentage, before we used that as the fraction. However, let's see how its application might be, so how different it might be. For example, let's say you have a square, yeah, you have the square. Let's take the square. Okay, and you know that, let's say each side is increased by 20%. So each side is increased by 20%. So what can you say about the area increase? So that's the common problem. So first, let's figure out the area percentage increase. Okay, the area percentage increase, and the second, the perimeter. So that perimeter percentage increase. Okay, so what can you say about area percentage increase and the perimeter? So, okay, let's take the square. So this is the square. And let's just simply calculate. So area by definition. So area of the original square. So area 1 for original square. Let's take your square was x by x. So x by x is simply x squared. Okay, now new area, new one, after percentage increase by 20%, so for each side, it means that now let's just simply drop your new square and let's see what's the size. So one side, because they're all sides equal, so you can consider just only one side. And if you have increased by 20%, it means previous value plus increase, but as the share, so 20% means 0.2 from x, right? So in total, you've got 1.2x, that's the side, one side of the square. And obviously the second side will have the same size. So that's why new area is simply 1.2x times 1.2x. In this case, you have, so this actually 1.2 is called multiplier. So this is multiplier. So what it means, it takes the effect of increasing by some percentage rate. So in this case, rate is 20%. Okay, so if you calculate what will happen, you'll get 1.2 squared of x squared. You just times numbers by itself and x by x. So percentage area increase. So what it means. So first of all, okay, let's calculate NU. So 1.2 squared. So you can freely use your calculator and just simply calculate. So let me see. Okay, so you've got 1.2 squared. 1.2 squared. You've got 1.44 x squared. That stays for area new. And how to find percentage increase. So area percentage increase, by definition, any percentage increase, so change in area as a percentage. So you take new value, you subtract your previous value, A1, and you divide by the previous value. So result, you multiply by 100%. That's how it can be worked out. Okay, so let's calculate. So in our case, percentage change in area will be simply 1.44 x squared stays for new, you subtract x squared and you divide by x squared. Now just remember how to work with algebraic fractions. So the result, you multiply it by 100%. So change in area, delta stays for change. Okay, you've got simply x squared factorized, x squared in the bottom part, and here you've got the following: 144 and you subtract 1, right? Because you grabbed x's, and if you take it away, so instead of this expression you get 1.44, and instead of this x squared, so it's wrong to think that you've got nothing. No, you've got 1, right? Because you can check yourself by reciprocal multiplication. If you multiply back, you'll get x squared times 144 minus x squared. That's correct. Okay, so now you see that all x squared are cancelled. And that's why finally you've got the following. So percentage change in the area is simply 0.44 over 1, so multiplied by 100. So as the percentage, 1, 2, it's going to be 44 percentage increase. So you see how it works. So you can figure out, so that it's not simply like 20 squared, right? That will be a mistake to think that it's so. Okay, so what about perimeter increase? So just remember how we calculate the perimeter. Let's see. So perimeter increase. So first of all, perimeter is 4x. So that's why you just have linear increase by 20%. So if you want to complete the formula for perimeter change as the percentage, you need to calculate new one. So that's previous. So that's new one minus previous over previous one. So that's previous perimeter 4x, and now new one is simply 4 times, and new side becomes 1.2x as we calculated. So we've got simply 4 times 1.2x. So don't calculate, just you see that later on you'll just factorize and you'll get 4 cancelled. Okay, so P new is simply 4 times 1.2x. Then you subtract the previous one, 4x, and then you divide by 4x, and the result you need to multiply everywhere by 100%, okay? Because you want to express as a percentage. So what you can do, so you can factorize 4, right? You can factorize 4, and you simply erase 4 from here. So that's why you're left with 4, cancel with 4. You can also factorize x from here. You just grab x and put it here, and you simply have percentage change in the perimeter as the same as percentage change for one side. So you've got simply 1.2 minus 1 is 0.2, and times 100 you'll get 20%. So one more time, the recap, okay, or outcome that you can work out from here. If you have increased one side of like linear size by some percentage rate, let's just recap that. So if you have, let's say, increase or decrease, let's say increase by some r percentage rate, so simply perimeter becomes proportional to the linear size. So linear size, right? And linear size, let's say side lengths and linear size have the same influence on the perimeter. So that's why your percentage increase for the perimeter is simply equals r. But what about area? So what about the area? Percentage increase in the area is proportional to percentage increase squared, right? As we figure out. So in our case it was 0.2 simply times 0.2. If you just recalculate, oh no, actually it was 44, right, percentage, because that was 1.2 multiplier. Yeah, there was 1.2 multiplier. So that's why, sorry, this is my bad. Not the percentage, but actually you need to get the new side, new one, which is 1.2 of the previous one. So, or simply 1 plus r. So that's the formula, 1 plus r squared, right? And you multiply by 100%. Okay, in this case you'll get your right answer, because if you use that instead of r, you'll use simply 20% or 0.2, and if you plug it here you'll get 1.2 squared, and then result you multiply by 100%. So, and because you're looking for the difference, right, that's simply change, not the change but a new one, right? That's new one, and if you subtract the previous value you'll get 144 minus 1, which is 0.44. Okay, so this is the way. So I don't recommend to, to memorize all the formula for that. Just simply try to work out as I showed you, and you will have like less chance to have the error. Okay, so this is the way how it works with areas. So also it can be applicable to volumes. Let's say you have cube, right? So you'll do the same. Let's say if you want to calculate with volumes. So volumes, if you still have 20% increase for the side, you just simply remember that volume of the cube or any like other rectangle. So probably it's cuboid. So instead of square, you might have rectangle. Instead of like cube, you might have cuboid. So anyway, volume is multiplication of all dimensions, right? All 3 dimensions. In case of cube, right? In case of cube, you'll get volume is a cube, right? Side cube. And if each side increased by 20, so you'll get 1.2 times 1.2 times 1.2. So which means you've got 1.2 cubed. In this case, if you calculate, so new volume becomes 1.728. And that means that if you make the difference, if old one, so old one is simply 1, right? You can make the difference and see that the result is 0.728 as a percentage, right? And if you multiply by 100, you'll get 72.8. That's for a cube. So you see the logic. I don't recommend to memorize all that. Just simply try to understand how it works, the main principle here. Okay, so that was about percentages. Okay, so what we can also do. So let's say we have some table and some data in the table. Let's take, you have amounts of money. So amounts of money, that's again percentages. So amounts of money. So you've got, let's say $10, maybe let's take $30. Okay, and you know that, let's take 5% of that. So you know what 5% from each amount, and you also know, let's say 10% of that amount. So you're given those data. So we can actually calculate. So probably in cents, but I'll give you just in dollars. So 5%, right? $0.5. And from 30, we've got $1.5. Okay. So we've got dollars here actually. Before, okay, doesn't matter where you put dollar sign. So then you take 10% out of, again, and 10% is $3. So you're given this table. So actually, that what are you given? And based on this table, so for example, you need to work out, let's say 15% of $60. Okay, so how it works? Simply, what you can do. So first of all, you have $60. Okay, you have the result for $10, right? You have the result $10, and if you calculate 15% of 10, so that's the first strategy, you can use that. So 15% of $10 is simply 5% and 10 together. So you've got $1.5. Okay, of course you can use, like, without using the table, you can also calculate. But if you're based on the table, you see the values where they come up together. So 5 and 10% together, you'll be given simply your amount of 10% or 15%. So that's why you can calculate first not from 60 but from 10, and the result just simply multiply by 6, because $10 is 6 times less than 60. So if you check, so okay, one more time, let's calculate. It's going to be $9, and if you calculate by 15% out of 60, you'll have the same amount, $9. Okay, so probably let's calculate some like weird amount. Say you need to calculate $6.75. So you're given that amount, right? 6.75, and you want to calculate as, let's say, 15% of which amount? Okay? So you need to calculate what stays 15% of which amount. So you need to figure out amount in dollars. So that 15% of that will give you 6.75. Okay, so what you can do, you're just thinking about, okay, we've got 6.75, yes, and this is the resultant amount of 15%. Of course, you can complete an equation without using the table. So 15% is simply 1500ths or 0.15 of some unknown amount x in dollars, right? X in dollars. From where you can figure out x amount in dollars as, let's say, 6.75 divided by 0.15. So this is the way through using the equation. Let's calculate that quick. And 0.15, you've got $45. However, there is another way around where you can figure out your amount. Okay? Let's say for this task, you might be given extra data. For example, you're also given extra data so that if you based on the table, you'll be able to do that. So you got extra, let's say $45, and you also given the amount 5% of that. Let's say 5% of 45, so it's going to be like $225. And also you're given 10% of 45, so that's simply $4.5. Okay, so based on these values, try to figure out like this amount. So we know the fair value, we've calculated using the equation, but now this is alternative way if you're given amount. Okay, so look, if you add up those values, you'll get exactly, so if you add them up, you'll get 675 in total. Okay, so what actually you're doing, you add in 5 and 10% of the amount, right? And this amount was 45. So what actually you are doing, you add 5% and 10% of the same amount that was 45. So that's why your answer is $45 here. Okay, that's how you can use data and calculate without any calculator. So you can also probably, let's work out, let's say quarter, right? So 1/4 of the dollar. Let's calculate what quarter of the dollar. Let's take, let me see, it's a quarter of the dollar. Let's take 5% of which amount? Which amount? Okay, so here you actually can work out using equation again. So one way of doing this is 1/4 in dollars. Actually 5% is 0.05 of x, from where you can figure out x is simply 1/4 divided by 0.05, but 0.05 I just write as 500ths, and then I simply using the division rule for fractions, I simply swap and flip their second fraction and multiply instead. So I've got this. Okay, and now you can cancel, right? You've got 25 over 5, you've got $5. So the actual result, so quarter is 1/4 of the dollar, yeah? So it's 5 from the $5, yeah? So it's 5. Seems to me something wrong, yeah? So, okay, let's check one more time. So 1/4 multiplied by 100 over 5, yeah? Yeah, that's 5%. Okay, so we've got $5. Let's check it so quick. So 0.05 multiplied by 5, we got 0.25. Yeah, that's all right. That's right. So this is the result for if you use the equation. But what if you're given this table? Is it possible to figure out 1/4 as a 5% of something? Okay, you just simply try to work out as the phone. So you've got 5% of something, and this is 1/4. So can you see 1/4 here? So actually, you've got only, let's say 5% of $10. So if you write 5% of $10, so you've got, as a result, you've got 0.5. So what about quarter? So quarter is simply 1.4, yes, and it's actually 0.25, right? So what about the numbers, the correlation? You've got 0.5, and now here you've got 0.25. So this amount is 2 times less. So simply it's 2 times less. So that's why your amount of the dollars should be also 2 times less. That's an alternative way. So that's why if you take 5%, not out of 10, but out of 10 over 2, simply $5, you'll get your quarter, or $0.25. So this is the way how using the table you can work it out. So actually what I recommend, if you're strong with equations, so go with that. If you stick to the table and can easily figure out the data from there, that's the tips for you guys. You're strong using visual information, so you can mentally, quickly and fast add up the data and understand what actually you're looking for. So that was the result for actually percentage, and that's how you're supposed to work with percentage. Okay, so guys, maybe let's stop for a while because it's pretty enough. We didn't cover the problem solving and system of equations and ratios. So ratios will be for the next time, and problem solving also for next time. That will be part 3. So hope you enjoy, hope you like this video. So we worked through estimation, again percentages, trying to apply to some problems, and there the next step is about ratios and is about system of equations and how we can apply them to solve the problems. All right, thank you and peace out.